and welcome to Podcast.init, the podcast about Python and the people who make it great. You can subscribe to our show on iTunes, Stitcher, TuneIn Radio, or add our RSS feed to your podcatcher of choice. You can also follow us on Twitter or Google+, and please give us feedback. You can leave a review on iTunes to help other people find the show, send us a tweet or an email, leave us a message on Google+, or leave a comment in our show notes, and you can also join our community. Visit discourse.pythonpodcast.com for your opportunity to find out about upcoming guests, suggest questions, propose show ideas, and follow up with guests of the past episodes. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for your next project. I would also like to thank Hired, a job marketplace for developers and designers, for sponsoring this episode of Podcast.init. Use the link hired.com/podcastinit to double your signing bonus. Your hosts as usual are Tobias Macy and Chris Patty. Couple of announcements before we start the show. There's the Open Data Science Conference that's happening in Boston, Massachusetts on May 21st to 22nd, and I've actually been given 2 free tickets to give to our audience at random, so if you sign up for our newsletter, then I will pick 2 lucky winners for those tickets, and also I'm going to be at that conference, so if you happen to be going on your own or get some of those tickets, then I'll see you there. So today we are interviewing Brett Cannon and Dino Viehland about their work on Pigeon, a CPython extension that provides an API to allow for plugging a JIT compilation engine into the CPython runtime. So could you guys introduce yourselves, please? Dino, how about you go first?
So I have been working at Microsoft on Python for a pretty long time now. I've worked on several different projects, Iron Python, Python tools for Visual Studio. I've at one point in time did a tiny amount of work on our Azure SDK and our Azure ML SDKs. So I may be the longest employed person working at Python at Microsoft in general at this point. And so last year I thought the idea of starting a JIT for CPython based upon .NET and maybe opening the world to have a generalized JIT was an awesome idea after the language summit or the runtime summit at PyCon.
And how about you, Brett?
Yeah, so I've been on the Python team with Dino since July, so nowhere near as long as Dino. Although I've been a core contributor to Python for, about going on 13 years next month. And after Dino started this little project of his, I got brought on shortly after I started work to kind of act, I guess, as program manager while Dino's tech lead to help keep moving this forward and kind of our spare time, part-time on it, and just trying to see if we can get it to go anywhere.
So how did you folks get introduced to Python?
So I actually, I'd heard about Python a little bit, but my real introduction to Python is quite strange in that I started learning Python by working on an implementation of Python, which was working on Iron Python. I had not really written any Python code before I started doing that. And so I came in it from a very odd direction and learned kind of all of the horrible, intricate language things that most people probably don't know while not learning all of the great standard library things that people know and love. So I had quite a strange introduction.
So I got introduced to Python in the fall of 2000 when I was looking for a programming language to learn object-oriented programming from. Where I did my undergrad, they had an intro, the intro course had a entrance exam. And I figured I should know, I already knew C at the time, and I figured I should know some object-oriented language, and Perl and Python kept popping up at the time. But everyone kept saying, oh yeah, Perl, it should be like your 5th or 6th language. Well, everything I kept reading said like Python was a great introductory language, so I decided to go with that, loved it, and haven't looked back since.
Did you ever get around to learning Perl?
Actually, I did. I went to UC Berkeley, and they allowed students to actually teach courses for pass-fail for 1 or 2 units, basically to pad out your unit count so that you were considered a full-time student. And some friends of mine at the Open Computing Facility, which was a student-run computer lab, taught an intro Perl class. So I actually took that. So I actually did learn it.
Great. So what was the inspiration for the Pigeon project, and what are its goals?
So I was inspired when Larry Hastings got up last year at PyCon and was talking about what it would take to help move people to Python 3. And he had a lot of interesting ideas, but the one that stood out in my mind was just making Python faster. And you look at the JavaScript community and you have a lot of competition going on amongst JavaScript implementations. And I think that has really spurred them on to be competitive and make better, faster versions of JavaScript. And so I'd love to see the same thing happen with Python. But really, it's in a world where you have CPython, and you have a couple of other distributions which are pretty significant, but their goal is really to run on different platforms. And then you have PyPy, and PyPy throws out a lot of the compatibility in order to achieve its speed. And so I thought there could be a way forward to add a JIT to CPython and potentially open that up to other people to add their own JITs and get sort of that same sort of competitive landscape going on.
What was your reasoning for going for a JIT implementation as your approach for speeding up the CPython runtime or providing a faster Python experience versus any other approach that might be taken?
I think, at the end of the day, getting out of the interpreter loop is going to be required to speed up CPython. And also being able to take runtime type information and flow that back in and make more optimal decisions. And so kind of all those things require having a JIT. There's a lot of other things that can be done to speed up CPython as well, but this can be done without changing anything else about CPython, which maintains the compatibility, and I think it should have a lot of room to grow in it as well. So those are the main two reasons.
So the FAQ mentions that Pigeon could easily be made cross-platform, but this being a Microsoft project, it was bootstrapped on Windows first. Have any of the discrete tasks required to get Pigeon running under OS X or Linux been laid out, even in sort of, vague outline form?
Yeah, actually, if you go to our GitHub page at github.com/Microsoft/Pigeon, which is Pyjion, there's actually an issue there to port our build file, which is a Visual Studio project file, to CMake, which is the same build system that the core CLR JIT that we use uses as well. So it's literally just been laziness on our part of just not learning CMake to port the build file over. And then verifying that our C++ is fully cross-platform.
I got to be honest with you, having locked horns with CMake on a couple of occasions, I don't blame you. It's a really powerful tool, but it does not exactly present a pleasantly shallow learning curve.
Yeah, exactly. And I mean, we could always do a custom make file just for Linux and OS X or any Unix platform, but then we've bifurcated between Visual Studio build files and then Unix build files, and that's just too much of a hassle. So this is the exact reason we haven't just gotten around to it yet, is just buckling down and then just doing the work.
So if any of our listeners out there is a CMake expert or even a CMake journeyman and would be willing to pitch into the project, this is your opportunity.
So, given that this is a Microsoft-backed project, it makes sense that the first JIT engine to be implemented is for the core CLR. What would an alternative implementation provide, and in what ways can a JIT framework be tuned for particular workloads? And also, I'm realizing that we're using the acronym JIT quite a bit, so maybe if you could also take a moment to just describe what JIT actually means.
So a JIT is a just-in-time compiler, and that is a compiler that gets invoked at runtime within your process typically and takes some intermediate representation and turns it into native code and then turns around and executes that immediately. You can contrast that with your normal program, which would be compiled ahead of time, and you have native code and you run that binary and there's no extra translation steps. So we chose Core CLR mainly because I long ago was actually on the CLR team and kind of knew how the CLR JIT was out and thought it would be a good thing that we could come and just drop in place. And Microsoft had recently open sourced it, so that made it just super ideal. We've already talked about one other JIT engine that we could use, which is Chakra Core. And so it's easy to kind of contrast some of the big differences there in that the CLR JIT's very much meant for static languages, whereas Chakra Core was designed for JavaScript. And so it has things like it's designed to bail out to an interpreter loop when optimizations aren't known to be true. It has facilities for pulling out local values of optimized code and various things like that that have been tuned for dynamic languages. So that's kind of one axis where things can vary a lot. Another axis might be using a more powerful compiler. So you have things like LLVM, which has tons of optimizations, which typically makes it not very good for a JIT because it takes a long time to compile and go through all those optimizations. But if you had some code that you knew you wanted to get as optimal as possible, something that's based off of LLVM might be useful. And that's, for example, what Numba, which isn't a generic JIT solution, but lets you write Python code and have it be JITted. That's what they're using, and that's what Unlaid and Swallow used in the past. Other things might be just raw compilation throughput. So LuaJIT is known to be a very efficient JIT at producing code and doing so quickly. And so that might be yet another axis that people could look at. And then, there's also, you could imagine some sort of meta JIT, which tried to pick which one was right and use any other various JIT frameworks. So lots of spaces to play around in.
It also occurred to me as I was hearing you describe these various axes, Core CLR has been around for a long time at this point, hasn't it? I mean, .NET has been under active development for, it's got to be at least a decade now, right?
Yeah, maybe 20 years. I joined Microsoft almost 15 years ago, and I joined the CLR team, and they were close to shipping and had been under development for several years at that point.
Now I feel old because I remember when that whole Sun Microsoft Java war, which led to the, directly or indirectly to the development of .NET. So that has to be an advantage when you're talking about using the CLR as the basis for something like this. It kind of reminds me of the hotspot jitter in the Java world. It's like you get these code bases that have been lovingly optimized and evolved for decades, and you end up with these really incredibly performant tools. It's got to be great to be able to leverage all that.
Yes, it is so awesome that it's open source now and that we can just pick it up. And like one of the big things I really didn't want to do is go off and write my own code generator, right? Like that is just going to be a gigantic rat hole, and it's not going to be that great. And, it's probably going to be buggy, and just having, like, there's now a choice of JITs from Microsoft alone, let alone all the other JITs in the world that are also open source. And so there's a lot of possibilities here. And so that is one of the inspiring things.
So you've listed off quite a number of different JIT implementations. Are there any aspects of those that would either lend themselves particularly well to being run against Python, or perhaps make them less ideal for running against Python? And do you think that there is room for somebody to plug in a different JIT engine that is more well suited to Python, perhaps even something built with RPython or PyPy itself?
So there are basically three goals we have for Pigeon in descending order of importance. So the most important one is this C API we've designed for CPython that we are going to we're hoping to get upstreamed if we can convince the Python development team to go along with it. And then because that's the key goal, basically using the core CLR JIT is more of a proof of concept and an idea. So we've designed the C API that we're using from the beginning to be fully pluggable, right? So as Dino said, JavaScript has had a lot of work, and it's extremely dynamic language and much closer to operating the way Python works in terms of being able to toss on an attribute on a random object compared to like C# or Java, where you have the hotspot VM or what Core CLR typically targets more. So honestly, we don't know what the best JIT is going to be, and that's one of the reasons we've made sure this is designed in such a way that anyone who wants to experiment and try that out and put the time and effort in has the opportunity to actually make this all work. So we don't know, and that's kind of the exciting bit and why we're hoping people, if we can get this C API put in upstream, can give it a shot and see what comes out of it.
And what kinds of use cases and problem domains that were previously impractical or even intractable do you think will be enabled by having this new capability with the CPython implementation?
I think that really remains to be seen. At this point, we have barely scratched the surface of doing any optimizations. My hope is that the big use case is that people don't have to go to C like they think they do sometimes now, or how they just simply sometimes have to do that today. But beyond that, I think first we need to prove that this is actually going to work, and then we can actually start seeing where it helps and where it doesn't.
I'm assuming that the answer to this is no, but would having your code compiled via JIT provide a way of sidestepping the GIL in some respects?
No.
Okay. That's what I assumed.
Yeah, well, the issue is it kind of honestly depends on what kind of compatibility you want, but we designed this from the beginning such that the C API from CPython is in no way a hindrance. It's just part of the system. So that immediately requires that the GIL be operational and in effect, because otherwise you're going to end up with reference counting issues, and you're going to leak memory or free memory that's not ready to be freed, and you're just going to have massive issues. So
right.
This has absolutely nothing to do with the GIL.
Yeah, and that would just introduce a whole slew of new security concerns, and Python being well known for having such a well-maintained and well-security audited code base, that would definitely be a pretty large black mark that nobody wants to introduce.
Yeah, I mean, getting rid of discussing, I mean, we can have a discussion about the GIL if you want, but trying to get rid of it is its whole own problem that we don't even want to attempt to tackle, on top of trying to prove that a JIT plugin system for CPython is tractable.
Yeah, we actually spoke with Trent Nelson, I believe his name is, about his work on PyParallel in another episode. So that was one approach of trying to sidestep the GIL. So we'll cut this line of inquiry short and move on with the other questions.
Does Microsoft's recent acquisition of Xamarin and the Mono project change things for the Pigeon project at all?
I don't think it really does. I think even in the .NET space, what you see happening with Core CLR is that Microsoft is taking its CLR implementation and making it available elsewhere. And I think the places where Mono really adds value in the CLR space are things like its ahead-of-time compilation, although the CLR has something for that now, although it's, obviously much younger than Mono's implementation is. And we're really focused on the JIT space, and I think Core CLR generally offers a better JIT than what Mono does. So for that reason, I don't see that being a huge delta.
And what are the challenges associated with your work on Pigeon? Are there certain aspects of the Python language and the CPython implementation that make the work more difficult than it might be otherwise?
Yes.
You're going to be able to stay calm while you answer this question, Dino?
So when I started this, my kind of thought process was, going to IL, which is what the JIT consumes, would be a fairly easy process, because CPython's bytecode is based around a stack-based VM, and so is IL. So, it's just move one over and translate, and we'll be done. So it turns out that CPython has a lot less restrictions on its bytecode than what the CLR has on IL. And a couple of those are the CLR doesn't let you transition to the same bytecode with varying stack depth. So that's because it needs to figure out what register each value of the stack is going to correspond with and generate kind of sane code. There's no real stack there. Whereas Python has a array, which is its stack, and it's just pushing things on and pushing things off. And so it can pop off a value and be like, what's this value? And then it can be like, okay, because this value was whatever, I need to pop off 2 more values now. And another thing that the CLR JIT doesn't like is significant flow control with values still on the stack. So you can't return from a function with values still on the stack. So these little differences have actually proven to be pretty challenging in coming up with a way that we can actually transform the bytecode into IL. And then exception handling has just been super interesting as well.
That's a nice way of putting it.
The CLR obviously has its own exception handling mechanisms, but we can't really use those. And so the big reason why we can't use them is actually it goes back to reference counting, in that we can't just throw an exception and unwind the stack and not decrement the ref counts on all of those objects that are sitting on the stack still. And so that works great in a garbage collected, non-reference counted environment, but in a reference counted environment, all of those dec refs have to happen. So luckily the test cases are very good for exception handling. And so we were able to beat it into submission, but getting all the nuances there correctly, getting them all working correctly has been a long bugtail. But
we did solve them in the end, which is the important thing.
Yeah.
So when I think of Microsoft and programming languages, I generally think of C++ and C#. Did your team have to go through an approval process in order to utilize Python and further to open source your work on Pigeon?
So I've been doing Python stuff at Microsoft for the past decade, basically. So dealing with LCA and Python, it used to be difficult. They didn't really have a problem.
We should mention, by the way, real quick, LCA is basically the legal department at Microsoft.
Okay.
Thank you.
Initially, they were fine with us using it, right? And in IronPython, they were fine with us distributing IronPython, but initially they didn't even want us distributing the CPython standard library along with IronPython. So IronPython was Python without the batteries included. And it has been a long time, but finally, and especially in the past couple of years, you really see Microsoft coming around. Getting Pigeon out was really, really easy. It was a couple weeks before we were ready to announce. We looped in our legal contact. They looked over the code. They're like, yeah, go for it. And so it's night and day from when I first started. And now it's just, I don't think they blink at the language really at all.
Yeah, and having just joined Microsoft coming from Google, I mean, the approval process is no worse or different. And honestly, I found Microsoft's easier to do open source Moodlighty work in my spare time easier than how I found it at Google. So it's definitely, from people's old perspective of Microsoft, just does not hold anymore in terms of the new current Microsoft and its view of how to deal with open source.
It must feel really great for those of you folks who've been there for a long time to be able to see that culture change happening, because, I mean, developers are developers, right? We all want to build cool things and we all want to share them with everybody. And so it's got to be nice to have Microsoft embrace this idea that if it's not a core competency and it can generate some goodwill and perhaps get more eyeballs and more mind share on Microsoft products, then open sourcing is a perfectly viable approach. It must feel awfully good.
It certainly does, especially after, 10 years ago, it was so different. And I've been doing open source at Microsoft this entire time. And so for me, I'm really excited about it.
So how does Pigeon hook into the CPython runtime, and what kinds of primitives does it expose to JIT engines for them to be able to work with?
If you look at our repository, we actually have a patches directory that's literally just a set of diffs that we apply to CPython 3.5.1. And essentially what we've done is we've extended code objects which represent code anywhere that gets executed. So even modules, for instance, are code objects. But mainly, most people think functions and methods. And we added a couple attributes on there. The key one is a pointer for a struct that we created to store JIT information, mainly a C function that can be set that acts as a trampoline, and kind of a scratch space, which is just a void pointer. And what happens is in the eval loop of the interpreter, when you come across a code object, we check if it's been executed enough to warrant execution, although currently for compatibility testing, all code is considered hot and ready to go to be compiled. We just check to see if a JIT compiler function has been set, and if it does, we pass the code object to it, and then get back the appropriate struct to store into the code object. And then when execution starts for that code object in the current frame, we pass in the frame, and basically that includes the code object and the information that was stored by the JIT compiler in there. So more or less, basically, JITs compile against code objects such that they can execute against a frame object. And that's basically it. It's honestly not terribly complicated. The complication, from an API perspective, the complication obviously is just be able to take Python bytecode and know how to emit the proper intermediate representation or language to actually make the semantics fall out.
And so when you actually do execute the compilation, does that then substitute the bytecode code path with a compiled C module?
So it's basically, if you look in Python in the ceval.c file, which has the eval loop, there's basically a function, I believe it's eval frame ex is the technical name, that the loop calls to start the execution of every frame object, so basically every function call you make. And in there, we literally just have an if statement that just says, all right, here for this frame, get the code object for the frame that we're going to be executing, and does this code object have the struct that we created to store the JIT information, which is the function with the trampoline and its scratch space and the void pointer. And if it's set, then just call that instead of going into the actual eval loop.
One question that I actually asked Maciej Fialkowski of the RPython and PyPy projects when we were speaking with him, I was curious whether it was possible to save the results of JIT compilations between code execution. And in his particular case, it gets cleared up when the program ceases executing. With Pigeon, and I'm assuming it's probably somewhat specific to the JIT engine being used, is it actually possible to cache or somehow store the compiled code so that the next time that the program gets run, you can skip the runtime compilation and just leverage the work that's already been done?
We don't currently do that. In theory, it would be possible just because Core CLR has this engine feature for pre-compiling code. There'd be a bunch of work of kind of doing some saving and then doing the pre-compilation stage and writing that all out to a module somewhere. So it would be non-trivial to go off and implement that, but theoretically possible.
And would it be a worthwhile endeavor to actually do that, or do you think it would just be a lot of work without much practical gain?
It may be worthwhile. Back on IronPython, one of our biggest challenges was always startup time. And a lot of our startup time was actually dominated by time spent in the JIT. And so one way we got around that was using .NET's engine feature where we could save all of the IL for even your Python code, and we could engine all of that and have everything be executable code ready to go. And that helped with our startup time a lot. I don't expect it to be as much of a problem here because Python already starts up so fast because the eval loop is very tuned and Python's been optimized and optimized and optimized. And so our main goal is to really fall back on the eval loop and let that be used for fast startup. And then we can JIT. Hopefully at some point we can start JITting in the background even. And so it doesn't even really affect your performance at all. That might start to get interesting if someone had something that they wanted to be both high performance and high startup. And maybe we'll cross that point, but probably a long ways out.
Another part of the project that you guys have worked on and I believe is already ready to use is an actual C++ framework for making it easier for other people to plug in their own JIT implementation. So I'm just curious what kinds of capabilities that will allow for and how that will ease the implementation for other people who want to do that.
So in general, that starts to change the bytecode into higher level concepts. And it's a lot of higher level concepts. There's a lot of helper calls that happen, but figuring out, for example, exactly how you write that tricky exception handling code, that can be figured out once, and then you can deal with actually turning that into the raw native code that needs to be created instead of figuring out exception handling again. We also hope to start doing type inference. We do a little bit of type inference to that now, but start applying that more deeply, and then doing type specialization. And so hopefully JIT implementers won't have to think about that stuff so much and can instead focus on how they emit the code for adding to integers.
And would the type module in Python 3.5, as long as it was leveraged appropriately, provide any advantages or benefits to JIT implementation to maybe simplify the work that needs to be done there?
It's theoretically possible. We just personally haven't done it yet. That kind of information is stored at the function object level, not the code object level. So technically, the JIT, the way the API is structured, does not have access to that information. But it honestly would not be difficult to have a decorator, say, much like Numba, that was at the C level as through like a C extension able to grab the type hints out of the type annotations on the functions and methods, and then burrow that into the code object for access for the JIT, and then the JIT could potentially take that information and then use that in its own needs for doing JIT compilation. So theoretically possible, but nothing yet.
And there is a question of whether or not people would really want to see that happen, in that you would then have code that could potentially execute under the JIT that would be different than how it executes in CPython normally, just because those type annotations are usually not enforced at all at runtime.
Right, and then there's also the risk that the type annotations are incorrect or not as complete as they could potentially be and might actually end up being more harm than good.
Yep, exactly.
Yeah, this is why anytime we've discussed this, it's been, yeah, this might be interesting, but if we did it, it'd be a decorator, much as I said, like Numba, where it's basically an opt-in feature where you basically promise, and if you crash your system, that's your own fault.
Right. So for somebody who's actually using Python with the Pigeon project and a JIT implementation plugged in, would the entire project be run through the JIT engine during runtime, or is it possible to target a subset of the code being executed?
Ideally, we'd only target the code that really matters. So before, when Brett was talking about how this plugs in, and he mentioned the fact that we have a counter, and we currently JIT every single method. So once we fall back to the counter mechanism, we'll only JIT methods that are hot. And that way, if you have something that just runs during startup once or whatever, it's never going to see the JIT at all. And that will need a bunch of tuning and smarts, and hopefully over time we can get that to the ideal spot where we're JITting the stuff that just matters.
Would that be an exposed parameter that somebody can tweak to specify what that threshold is for how many times through a loop the code needs to execute before you actually kick in the JIT?
Absolutely. It could be exposed, and it probably will be as one of the -X command line options. And, that is a bit of a heavy hammer. So you could also even imagine just having some sort of JIT module that you can import that has some decorators that says, JIT always compile or JIT never compile and things like that. And if people can agree on some common sort of annotations that they'd want across several different JITs, inlining is frequently something people care about and want to tune, then you could imagine some standard module that lets people opt in at the method level.
In what ways can a JIT compiler implementation be purpose-built for a given workload, and how would somebody go about creating one?
I think the biggest example of that is if you look at Numba, where you have a JIT compiler, which is very much designed for doing numerical code and generating that and making that efficient. Going out and creating one, that is a lot of work, no matter what you're trying to do. So I I don't know that there's an easy how-to guide.
Yeah, I mean, there's a reason why there aren't very many JITs floating around in the world, and those that are usually because some corporation has decided it's really necessary to exist, such as all the JavaScript VMs and that whole speed war that the browsers have gone through. But to answer Tobias's question about specificity and to really kind of hammer on how Numba does it, for instance, Numba has support for GPUs, so they're able, because they focus on numerics so much, to actually JIT their code using LLVM down into the GPU usage, and so they're able to get very specific performance and great performance increases in their specific use cases. But once again, they're relying on LLVM because, once again, JITs are not necessarily an easy thing to do, because if you really think about it, what you're trying to do is write a compiler, more or less, right? Because what these JITs do is emit assembly in the end that the CPUs get compiled instantly for. So you're basically writing a compiler.
So could a JIT plugin be designed with different trade-offs, like no CAPI compatibility, but that worked around the GIL to provide real parallelization in Python?
So if you look at something like PyPy, I think the answer in some ways is obviously yes. I mean, PyPy in many ways is a JIT, but in order to really break CAPI compatibility, you really need a lot of other things changing than just the JIT. Working around the GIL, I think Numba's GPU-based math is going to probably be a good example of that, in that GPUs run things in parallel. As long as you know kind of that your inputs aren't random Python objects that you have to interact with while holding the GIL, you could release the GIL and do whatever you want with whatever your inputs are. Like if it was just a bunch of numbers, you could have something that ran without the GIL, did all of the math without the GIL held, and then returned back to Python and produced the actual number object with the GIL held again. So there is some possibility there, but I think you're quickly going down the path of creating a whole new runtime, or you would have to do a bunch of deep understanding of types in order to understand when you can release the GIL. And then there's the question of, are you actually doing enough work where it makes sense to release the GIL? So it's complicated, but certainly possible.
I guess my reason for asking is a number of episodes ago we had a guest on, Jessica, and I can't remember her last name. Tobias, you might know.
McKellar.
McKellar, thank you so much, who is a former president of the Python Foundation, and she talked about a lot of work that they're doing to make sure that Python is not just the popular programming language, for education and other uses today, but for 20 years from now. And I wonder, is the GIL going to hold Python back in that capacity? Because I see so much happening now with languages like Go that have some form of parallelization built in out of the box. I kind of feel like I understand why Python was designed the way that it was, but I also can't help but feel that, maybe there's nothing stopping Python, the language, as opposed to Python, the implementation, from having really good parallelization as well.
Well, another language that you could look at for an example of something that might be more feasible for the current way that Python is run is Erlang and the actor model, where rather than relying on a threaded model, you rely more on message passing and using that as your method for scaling out.
And JavaScript is an example of another. You don't have threads in JavaScript, right?
Right.
When you do have any parallelization, it is done through more of a message passing way.
Right.
Yeah, so at least for me, having been a core dev for 13 years, this question's come up a lot. And I mean, there's a couple things to answer what Chris said. So, for instance, the Go creators really like to harp on concurrency versus parallelism, and that Go is concurrent and not necessarily parallel. So, for instance, for the longest time, the default setting on Go was to use a single CPU and not actually parallelize anything using threads. So that is not always necessarily been a thing for Go. The thing with the GIL is it only is an issue if you are CPU bound. And the real issue with that is if you're IO bound, it really shouldn't matter, right? If everything that does networking is going to release it properly, and if you're doing something like using the concurrent.futures module, you'll get to take care of that perfectly fine. if you are using Python 3.5 or even 3.4, you can use any of the new asynchronous event loops we have, and it's dead simple now. Well, not dead simple, but much simpler to write asynchronous networking code. So once again, I/O bound stuff is not difficult to deal with. It's purely the CPU bound stuff, which some people obviously have, but some people don't, honestly. And you have to be running for a decent amount of time for that to really kick in. The other thing that really becomes an issue with all this is the GIL is baked into the C API. So the only way, honestly, at least for CPython, to get rid of it is to break the C API, more or less, which would break every C extension module out there. So the Python community, if they wanted CPython to get rid of the GIL, would have to make a decision to no longer use the C API as is.
Right.
And we would either have to design a new API that worked, or honestly, some people have talked about completely not even having a C API and only having a foreign function interface, as most languages do. So it really comes down to what kind of pains are people willing to put up with in a transition. And we've done the Python 2 to 3 transition, and I don't know if the community really wants to go through something similar with the C extensions. And I should also mention, by the way, PyPy has a GIL itself. So it's not like the fastest Python implementation out there doesn't also have a GIL. So I sometimes think the GIL is kind of a bugaboo for why isn't Python as fast as anything else out there, versus sometimes it's algorithms, sometimes it is an issue, but it's really, I wonder sometimes how much it's truly an issue versus just something people like to point at and say, this is holding me up, without fully understanding why.
I think you may very well be right. And first of all, I just wanted to clarify that what I actually meant here is concurrency, not true parallelism. Because you're right, Go for a long time was concurrent, not truly parallel. And secondly, I think you're entirely correct that this is mostly a mind share issue, right? Like what I was addressing was, I'm seeing people choosing, rightly or wrongly, languages like Go because they perceive that Go has better support for concurrency out of box than Python does. And so maybe the answer is we already have rockin' concurrency support. We just have to market it better. Do you know what I'm saying?
Oh, yes. And Go is the one everyone always brings up because at least a year or two ago, it was the one that seemed to be stealing people who were saying, oh, I'm not going to port my code to Python 3. I'm just going to rewrite my entire stack in Go instead and get some benefit. But for instance, Ben Bangert at Mozilla, who used to be big in the Python community because he helped start Pylons, he ended up doing a lot of Go work server-side for Mozilla. And they always had the common issues that people had with Go. For instance, testing is a real pain in the rear in the language. And I speak from experience on that. What ended up happening was Ben decided, okay, why don't we try rewriting this service in Python 2.7 with Twisted? And in fact, he actually used PyPy and Twisted, and he did it. And what happened was he actually got less memory usage than Go, because Go actually had more memory overhead per Go routine than Python did with Twisted. And then performance-wise, they were totally able to meet their performance needs with just CPython 2.7, but with PyPy, they were completely way ahead of any perceived or planned capacity needs. So they actually found out that while Go might technically be faster, it was completely unnecessary, and they were able to completely blow past like test coverage, rewrite the whole thing in 2 weeks, and make the whole thing much more productive in terms of management and maintenance than they ever had with Go. So once again, it's one of these things where we all love fast, which is why Dino started this project, right? Is trying to give people a way to get faster. But the key thing here has always been Python's other strengths, such as ease of use and ease of learning and ease of maintenance and everything else, and having to balance that with what potential real or thought of performance issues actually are. So we're doing our best to try to deal with that boogeyman of, let's see if we can make it so you can plug any JIT that people have adapted to use with CPython, assuming we can get this in, of course. But honestly, I want to get to the point where people just stop bringing up the GIL as a thing and just go, is Python fast enough for my use case, period. Don't worry about the technology behind it. Just, can I make it work with the tools I have?
Yeah, I think that's definitely sort of a good mindset change that we should be working to get the community into, because I think simply the way people are communicating about things is hurting the language a little bit. And just also another thing you mentioned, sort of the testability and performance. I think another thing that, in addition, in ease of learning with regards to Python, another thing it brings to the table is a very high level of abstraction. That's one of the things I love about working in Python. I've gone through a number of the tutorials and I've done a little bit of Go. I haven't really sort of written it in production. But one thing, and I know Go's adherents love this, Go forces you to think at a much lower level of abstraction than Python does when you're actually coding. And I think for a lot of people and for developer velocity in a lot of regards, that's a trade-off that needs to be taken into account. And we should be marketing accordingly.
Yeah, I mean, I think the real key point here is the global interpreter lock is an implementation detail of one or two implementations of Python. That's it. Like, people aren't coming to us complaining about other implementation details of C Python, which they could potentially. It's just for some reason people have really latched onto this one implementation detail
Right.
and just have made it the boogeyman of Python performance, instead of going like, maybe we should use a register-based VM instead of a stack-based VM, or we should be caching more, or all this other stuff, such as making it so it's easier to do AST transformations. And by the way, all this stuff I just mentioned, people are considering actually testing out instead of putting all this time and effort into worrying about the GIL, where it would have massive breakage issues with C extensions. So I just, as you said, I think you said, Chris, is as a community, I think we kind of need to just stop worrying about the GIL behind the curtain and just worry about the language overall itself, and think of just maybe other things that could still get us performance boosts, and not this one thing that's extremely difficult to tweak that may or may not even get you a boost, right? Because honestly, people have actually tried removing it in the past, and
it was much slower, yes.
Yeah, you have to scale up to several cores in order to break even, right? Like, I believe at previous times it took like at least 2, if not 3 cores to see any benefit. And while it's great that we all run on multi-core machines, you still are also competing with everything else on these machines that are multi-core and trying to use the CPU. And there's no guarantee you're going to get scheduled the way you want and all that. So there's no guarantee that even making this fully parallel is even going to be that great of a benefit.
And then, too, you're still running into the issue of shared memory space and all of the difficulties that brings up, whereas going more along the message passing model, it greatly reduces the shared state that needs to be managed, which simplifies the way that you can think about your problems, and also decreases and in some cases eliminates that whole class of bugs. So we should be focusing more on improving our conceptions of message passing among multiple processes, and perhaps maybe decreasing some of the runtime overhead of the multi-process module, so that we can, if we wanted to, scale across multiple CPUs in that regard.
Yeah, I mean, or making like multi-interpreter single process work better or something. I mean, basically, if someone wants to get rid of the GIL, they have to not only make it work in Python, but then also be willing to go out and convince the entire community that they need to scrap most of their C code. So that's why it's not just been done at a drop of a hat.
And also, not to dwell too long on this, but there have also been a number of performance improvements in most of the recent releases of the Python 3 series in various areas. I know that there were some drastic speed improvements in some of the standard library algorithms. The one that's coming to mind most readily is being able to do the walking the directory tree, and the algorithm that was used for that, I think, got something like a 20 or 30% speed improvement. So for those particular use cases, you can definitely see some movement happening. But anyway, so speaking of performance a bit, and
honestly, to touch on that real quick, a lot of work's actually going into Python 3.6 that I don't think people are aware of yet, because it hasn't landed in the Mercurial repository. But for instance, Victor Stinner of Red Hat, as part of his OpenStack work, has 3 PEPs open right now, all doing different things to try to improve performance. Yuri Slivanov has taken one of Victor's PEPs and added some caching at the bytecode level, and is seeing 5 to 10 with, in some cases, up to 20% speed improvements. So once again, it's one of these things where performance has also continued to increase, and it's worth also, as always, checking out the latest version of Python to see if your workload is actually improved with some change we've made.
And bringing it back around to the topic at hand, what kinds of performance improvements have you seen in your experimentation with the Pigeon and Core CLR JIT implementation?
Not very many so far. Right now, startup time is way, way worse. We have a couple of benchmarks where we get small improvements on, a bunch where we are the same, and some where we are worse off. But we haven't really even started doing much tuning on it yet whatsoever. We just finished up going through the entire test suite and making sure that we can run and pass all the tests modulo a few exceptions that we're going to address at some point in the future. But we wanted to make sure that the JIT was working properly before we really moved on and started conquering performance. So from here on out, we're going to start looking at some performance improvements and see if we can get some real world gains for at least some test cases.
And do you guys have a target release of Python that you're hoping to have Pigeon incorporated into?
So we have a talk at PyCon US this year on Pigeon that we'll be presenting. Our hope is to have a Python enhancement proposal written and ready to be presented to the Python development team at the Language Summit at PyCon this year to get a yes/maybe/no feel from them of, does this have the API changes we want to make, if they have any chance of either going in provisionally, or no chance in hell, don't bother. And then based on that, it's going to kind of depend on where it goes. But since we already have a working implementation and have the patch ready to go, it could very easily end up going into Python 3.6.
That would definitely be a pretty exciting step forward. And with the other peps and work that's happening on 3.6 that you mentioned, that sounds to be definitely a release for everybody to keep their eyes on.
There's even cool new features coming in too, like the new format string stuff. I don't know if you guys...
Yes, I did see that. That actually is one that I'm very interested in. And actually, I believe it was you who I heard mentioning recently that actually provides some additional performance improvements over the standard either percent encoded or string.format methods.
Yeah, for those of you who don't know, Eric Smith, the implementer of stir.format, actually has implemented string interpolation where you don't have to call .format anymore. Basically, you use the same syntax, and you can specify variable names in the curly braces, and it will directly substitute it. But because it's syntax now, because you use the F prefix, much like the U prefix from Python 2 for mentioning Unicode, the compiler can notice that you're doing that, and it's able to tease out the string literal, realize where the code is, and it basically becomes kind of a big stir.join call with proper calls to the format built in. And because all that's being done at the bytecode level, it's able to actually operate faster than using stir.format or the old modulo percent way of doing string interpolation. So once again, another really nice feature coming out in 3.6.
So one of the most notable benefits of having a JIT implementation for the CPython runtime is the fact that modules with C extensions can be used, such as NumPy. And I'm wondering if that poses any difficulties in the compilation methods used for optimizing the Python portion of the code, or if there's any special handling that needs to be done to make sure that you're not recompiling already compiled code.
There's no special handling that needs to happen. From our perspective, we are just going to invoke the helper function to do a call or to access a member or whatever. And so from that standpoint, we don't have to do anything special. And that sort of fallback code is always going to exist. As we get into optimizing things, we want to stop going through the helper method to look attributes up. Instead, know what attributes are there ahead of time, know what method we're calling ahead of time, things like that. So instead of being a challenge in any way or a difficulty, it will be an opportunity. And that would be somewhere where we probably want to figure out how a JIT can interface with C extensions in a generic way. You know, can a C extension expose an API that says, here's a function that is really only going to take ints. I have a version that'll work on 32-bit ints natively, and you can call this instead of calling a version that works on boxed ints, for example. So there's some opportunities there, but we can ignore it as long as we're just focused on optimizing pure Python code.
Has any thought been given to making Python a first-class citizen in Visual Studio Code?
There has been thought. We would like to do it. So, my time is spent on a lot of different things, but most recently I've moved back to Python tools for Visual Studio and I've been working there. And some of the work that we're doing there is really just in preparation for taking a lot of the services that PTVS has and making sure that we can expose them to VS Code. Because one of the issues there is that we don't get to run C# inside of VS Code. And PTVS is all C# code, but it has a lot of great features around the analysis of your code and things like that. So we are going to make some progress in preparing for that, but there's still a bunch of work that needs to be done on the VS Code side of things to integrate with whatever we end up with there. So we'd love to make it happen. It's just a matter of priorities and timing.
I totally understand, and I guess you really answered my question in that I just sort of discovered VS Code the other day as a result of an episode of the JavaScript Jabber podcast where they showcased it. And I don't do a lot of JavaScript development, but what little I do, I was very impressed with VS Code. I mean, I'm a Mac user. I'm just not a Windows user. And it's so nice. They've done such a really great job with the JavaScript integration that I think if it could ever get to the point where VS Code had that level of Python integration and support, I think that would give PyCharm a run for its money for sure.
Yeah, I mean, I actually personally use VS Code now instead of Atom, and I've been loving it. So, I mean, as Dino said, it's planned to happen. It's just a matter of, time and resources and being able to get around to it. But we definitely want to do it.
So what areas of the project could use some help from our listeners other than the CMake contribution that we sort of said would be really nice earlier with regards to making it cross-platform?
Well, we have some, basically at this point, because we've more or less reached compatibility, there are some things that could probably stand to be optimized, and that's really where we're focusing now. If you look at our issue tracker, we have a couple things lined out in terms of simpler, although I don't want to mislead people as in it's completely, anyone could just walk off the street and try, but if you're willing to get into MSIL and learn how the core CLR's intermediate language works, there are some things you can do to try to help us optimize the emission of that stuff. And then there's some higher end stuff, right? Like we aren't tracing types at all, and the way we've structured our C API, it wouldn't be hard to put in a trampoline in the code to actually trace the types through, and then sometime later use that information to actually do some compilation. So it varies from simple, like let's make ROT2 or ROT3 bytecodes work better, all the way up to let's see if we can actually trace types through and actually use that. So if people are kind of into optimizations, that's probably where we can currently use the most amount of help.
And another area might just be trying it out. We don't make that very easy right now because we don't have binaries that you can download. But, if you have some workload and are willing to build it, then you could download it, build it, run it, and report back any issues.
See, that's why we need some enterprising listener to contribute that CMake file so that people like me who don't run on Windows boxes can help with that. I'm partially blind, and until Windows 10, Windows meant eye strain for me. So that makes a lot of sense. And hopefully, somebody will at some point, or you guys will contribute that CMake file so more of us can sort of dive in and give it a try.
Is there anything that we didn't ask that you think we should have, or anything else that you want to bring up before we move on?
I think that was pretty good.
Great.
Yeah, no, I don't have anything specific.
Okay. So for anybody who wants to keep in touch with you guys and follow what you're up to, what would be the best way for them to do that? Dino, how about you first?
You can see what I'm doing on GitHub all the time. There's our Pigeon repository, there's the PTVS repository. In theory, I'm on Twitter and have a blog, and I never post anything.
Okay. And Brent, how about you?
Yeah, so unlike Dino, I am on Twitter and somewhat active. So you can find me at Bretsky, BRETTSKY. I also blog at snarky.ca, SNARKY.ca. I should also mention that our team has actually started a Python Engineering at Microsoft blog. So if you just Google Microsoft Python Engineering blog, you should come across it. And we're starting to try to post a new thing about every week or two, and that's probably another good way to keep up with what we're all doing.
Excellent.
Such as the recent blog post about Python 3 PyPI releases being more favorable to Python 3 than Python 2 starting in May this year, projected. In case you guys didn't see that blog.
No.
I did not. I'll have to take a look.
Yeah, it's pretty exciting.
All right. So with that, we'll move on to the picks. So for my first pick today, I'm going to choose the Logitech Wave keyboard and mouse combo. So I started a new job recently, and at first I just had a standard issue, straight, flat keyboard, and it was not very much fun to try and use, particularly since I've gotten used to that Logitech one. So the Logitech one just has a very nice contoured shape that makes it much more comfortable for typing and using. I've been using it for a while now, and it's been great, so definitely recommend checking that out for anybody who has an uncomfortable keyboard. And my next two picks are just tools that I've been able to leverage more recently with my new job. So SaltStack is a very advanced and flexible and utile piece of technology. We actually had Thomas Hatch on as, I believe, our first interview for this podcast. So
it was.
Go back and take a listen to that. But it's just amazing the different things that you can do with it if you approach it with a proper architectural design sense. So it's essentially a way to make your entire infrastructure event-driven, reactive, and fully automated if you have the vision to see it through. And along with that, I've been using the Test Infra library, which is a PyTest plugin that that provides some primitives and makes it easy to hook into actually run unit tests against your infrastructure. So I've been using that in my development cycles for developing SaltStack formulas in Vagrant machines to make sure that what I'm writing and executing is actually producing the outputs that I'm hoping it will. So good combination. And there's actually a cookie cutter template that I have on GitHub. So if you go to github.com/mitodl/saltstack-formula-cookie cutter, I think is what it is, you can check it out there. And I plan to write a blog post about it at some point, but just working on finding the time for that. So with that, I will hand it to you, Chris.
Thanks, Tobias. My first pick is an iOS app. I hope they do an Android version because a lot of Android people have been asking for it, but there isn't one yet. It's called Anchor, and the tagline is Public Radio for the People. As I mentioned a couple minutes ago, I'm somewhat visually impaired, and so this app has been really, really awesome for me. It is a new kind of social network that is strictly audio. You literally have conversations with other people. So you post what they call waves, and you can use different sort of keywords and hashtags and the like to sort of signal, what's in them. And then people can post replies. And so you end up with these really sort of interesting, topical yet somewhat meandering conversations actually had using people's real voices. And for me anyway, that lends a whole different sort of, mindset towards social media interaction. It is fundamentally different, at least to me, and others have said this as well, when you can actually hear another human being and their voice, which conveys so much depth and so many details about them on the other end of, the internet connection, as opposed to just seeing text on a screen. I've been having great fun with it, and I recommend it highly. It's great. My next pick is another sci-fi series called The Magicians. It's not quite as sort of high rent in terms of effects and writing as the other that I picked recently, but it's very entertaining. And if you like sort of, magic fantasy, that kind of thing, that kind of fiction, you might enjoy this. My final pick is a YouTube episode of a YouTube show that I really like called PBS Game Show from PBS Digital Studios. It's a recent episode called Portal is a Feminist Masterpiece. And it is a discussion of how the Portal games from Valve were written by an ardent feminist and are, in fact, a feminist masterpiece. Really interesting things like, your character in Portal is actually GLaDOS' daughter, and GLaDOS is actually, a really driven woman scientist who ended up being sort of, imprisoned in this AI. And it was just a really interesting analysis and really well done. It's definitely worth watching. And that's it for me. Brett, what do you have for us for picks?
So in honor of my wife, Andrea, who is quite the tea nut and has gotten me into tea, I got a couple tea-themed ones. First of all, I have something called the Breville Tea Maker, and it's a little pricey. I think it retails for maybe $250 or $300 in the States. I happen to be in Canada, by the way. But it basically is a fully self-contained tea-making device. It's pretty awesome. Basically, you fill the jug with water. You put your tea in this metal basket that sits on this magnetic vertical rail, and you choose what type of tea you're brewing, whether it's oolong or black or white or whatever, and you click brew, and what happens is it has a temperature sensor, and it heats the water until it gets to the right temperature. Once it hits that, the magnetic rail lowers the metal basket with the tea down into the water, times how long it brews, raises the basket, then back out of the water, and then beeps saying that your tea's ready. So you have perfectly brewed tea every single time. There's no more having to pour it, having to worry about how long it's been sitting. There's even a keep warm option. It's fantastic, and I can't recommend it highly enough for anyone who likes loose leaf tea. To go along with that, my second pick is Bodum mugs. They're glass, but the nice thing is that they're double walled, and you can't feel the heat from tea. So if you pour it, you don't have to worry about whether or not the handle's going to be too hot or not, because the double wall keeps it completely cool. We actually have to warn people when we hand it to them, don't drink the tea just because the mug feels cool, because it insulates so well. So those are the two big tea-themed ones. And then I guess as the third pick, I'm actually going to recommend a little game I've been playing on my Android that just came out recently called Altos Adventure. It was out on iOS originally, and it recently got released on Android on a freemium model. And they've really done a really good job. It's basically a little infinite runner where you are a guy in the Alps on a snowboard trying to collect runaway llamas. It sounds silly, but it's actually a lot of fun. And they've done a really good job with the leveling, where they've made the goals just enough that you have to try a few times to get them, but not so difficult that there's no way to get past them. And honestly, if you really get stuck, you can choose to skip them. But the mechanics are great. It's nice graphics, the music's good, and the progression seems to have been really balanced out really well.
I think I picked that one myself a couple of weeks ago, and it really has surprised me because I'm terrible at runner games because they're all, Twitch coordination based, and I don't have any. But the thing is just so beautiful and just so well put together that I find myself still going back to it and playing it anyway, just because I want to see the landscape go by, and the game design is so nicely designed that I really want to try to get to that next section. So definitely a really exceptional game. I'm glad it came to Android.
Yeah, it does kind of, honestly, to me, feels like almost like the Infinite Runner version of Monument Valley in terms of...
All right, how about you, Dino?
All right, I only have one pick. It's this British reality TV show called Come Dine With Me, and I caught some episodes when I was in London over Thanksgiving this year. It is just a hilarious, great, fun show. It's 4 contestants show up, and they come to each other's houses night after night. So each night, one of them hosts and prepares a meal. And some of these people have no idea really how to cook. Some of them are actually decent cooks. They sit around, they drink some wine or some champagne or some beer, and just hilarious antics ensue every single time. And then at the end of each night, the other 3 who are not cooking get to rate their counterpart, and it's just a lot of fun. And so since November, I've been watching it. There's 37 seasons, and they all appear to be on YouTube just about. So you can probably just watch this show for the rest of your life.
All right. I'll have to take a look at that. So I definitely appreciate the both of you taking time out of your day to come join us and tell us about your work on the Pigeon project. It's been a great conversation. Definitely very interesting work. I definitely look forward to seeing it become part of the standard CPython runtime. So thank you very much.
Thank you, Tobias and Chris.
Thanks, guys.
All right. Have a good night.